Welcome to my channel Sai Suriyas Academy. If you are new to my channel, then hit the subscribe button and press the bell icon for more interesting videos. We had been already discussing the various type of conversion in the number system conversion series. In this series, we are going to discuss about 4-bit binary coded decimal systems. The 4-bit binary coded decimal system consists of two popular techniques, which is called as the weighted 4-bit BCD code and then XS3 BCD code. In today's video, we are going to discuss about how to convert a decimal number to weighted 4-bit BCD code. Similarly, how to convert a decimal number to XS3 BCD code. Here a table has been given, which consists of decimal digits from 0 to 12 and the concerned weighted 4-bit BCD code. This weighted 4-bit BCD code can also be called as a 8421 BCD code. Since it considers the positional values of each digit, it is called as the 8421 BCD code. For 0, it is represented as 0000. So, in the weighted 4-bit BCD code, we are having only decimal digits starting from 0 to 9. So, from 0 to 9, the values has been represented. But in the table, we had written 10, 11 and 12. This is for the XS3 BCD code values. When we are discussing about the XS3 BCD code, we will get clear about why I had written 10, 11 and 12 values. Okay, now move on to the weighted 4-bit BCD code, which is called as a 8421 weighted code. Consider this example. Consider a decimal number 6359. A small tip. Suppose if you can't be able to remember the concerned 4-bit binary values of a concerned decimal digit, then how we can be able to evaluate the table is consider a number 9. When we have to continuously divide it by 2. The remainder has to be noted and the final value has to be written from the bottom to the top. Consider a value 9. It is divided by 2. We get quotient as 4, remainder 1. Again divided by 4 divided by 2. 2 2s are 4, remainder 0. Again 2 divided by 2, 1 2s are 2, remainder 0. So by returning from bottom to the top, we get 1 0 0 1. That is the value. Consider here 9, we are having 1 0 0 1. Similarly for other values, you can calculate on your own. Now consider the decimal number 6359. We want to convert it into the weighted 4-bit BCD code. So from the table, you can directly find the answer and substitute the answer, or else we can divide the number by 2 and using this method, we can be able to find the 4-bit binary value. So for 6 from the table 0 1 1 0. For 3, 0 0 1 1. For 5, 0 1 0 1. 9, in the example I had calculated here 1 0 0 1. How I had calculated 9? Similarly for other values you can be able to calculate on your own. Suppose if you can't remember the full table. So now the values has written and the 8421 BCD representation is the whole value is written as 0 1 1 0 0 0 1 1 0 1 0 1 and 1 0 0 1. This is the 8421 weighted code. Now consider XS3 BCD code. There is a small difference between a weighted 4-bit BCD code and a XS3 BCD code. Here the base idea is we want to convert the decimal number to the XS3 BCD code. Since it contains the positional values of each values, it is called as a non-weighted BCD code. The base idea to convert is, consider 183. We have to add 3 to the each decimal digit. And the concerned decimal digit for we will attain again a decimal digit. And again for the decimal digit, we have to substitute the weighted 4-bit BCD code. That is after adding the digit 3. Consider an example 183. So each number is written in each line 183. For 1, 1 plus 3, 4. For 8, 8 plus 3, 11. For 3, 3 plus 3, 6. So for 1 plus 3, 4, the concerned weighted 4-bit BCD code can be written. For 4, 0, 100. For 11, 1011. For 6, 0110. That is, we are substituting after adding, we are getting a decimal value again, and for this decimal value, we are substituting the weighted 4-bit BCD value. A very simple substitution and very simple method. And again writing all the values 0100, 1011 and then 0110, which is the attained answer. Here in the table, for weighted 4-bit BCD code, that is 8421 weighted code, the decimal digits consist of only 0 to 9. So only 0 to 9 can be needed in the table for the first method. Then when considering 0 to 9, here we are adding 3. So for 8, 11 we are getting. Suppose if we have here 9, the values when added we will be getting 12. So 10, 11, 12 values are represented for XS3 BCD codes. That is the maximum decimal digits we can have from 0 to 9. And when adding 3 also, we can get the values as maximum as 10, 11 and 12. So till 12 it has been represented the 8421 BCD code. Okay, a small recap. A weighted 4-bit BCD code, that is, here we are discussed about 4-bit binary coded decimal system. This binary coded decimal system can be represented as BCD in the short form. It consists of two popular techniques, weighted 4-bit BCD code and XS3 BCD code. And here the table is given, the concerned decimal digits and their concerned 8421 BCD code. Consider the decimal number 6359. Directly from the table we can substitute the 8421 BCD code values and then write again in the answer. Suppose if we can't remember the table, then consider the binary digit divided by 2 until it reaches a minimum value. Write the reminders and finally write the answer from the bottom to the top. For each number you can find on your own the 8421 BCD code. This is the first method. And in the second method, consider the decimal number 183. The base idea is for each digit we have to add 3 and again the decimal value is attained. For the attained decimal value, we are substituting the 8421 BCD code and finally the answer is written for 183. Here we are getting as 4116. So for 4116 we are substituting and the answer is written here. Okay, that's all for today's video. Keep supporting Sai Suriyas Academy. If you want to check the previous videos, check the number system conversion series which is in the playlist section, and in the description also the link is given. Thank you for watching my video. Keep supporting Sai Suriyas Academy. Thank you.